So delta T represents temperature change. It can either be the increase in the boiling point, or it can be the decrease in the freezing point. I stands for what we call the Van Hoff factor, all right? And again, we'll talk more about it on Wednesday during class time. But if we're talking about a molecular compound, basically anything that is not ionic, we're going to have an I value of 1. Because when we go back to talking about sugar dissolving into water, the sugar doesn't break apart. The carbons and the hydrogens, the oxygens, they don't break apart. It's one sugar molecule. So this I number represents the number of particles that whatever the solute is, the number of particles that it breaks down into when you dissolve it into a particular solvent. And then I, Van Hoff factor, if it's an ionic compound, what we're going to do is I is equal to the number of ions formed when the ionic compound dissolves. So, for instance, if I dissolve NaCl, I would be equal to 2, all right? So if that's sort of our example, because it's going to be an Na ion and a Cl ion. Now, I'm going to come over here to you, Stella. If I were to dissolve AlCl3, AlCl3 is a metal and a nonmetal, so it's definitely ionic. How many Al ions are in this formula, Stella?
1.
1. How many Cl ions are there?
3.
So how many total ions do we have?
4.
Yep. And so the Van Hoff factor, the I that we would use for this formula, would be equal to 4. Okay. What if I gave you something that looked like this? Thank you, Stella. If I go with Mg, and I'm not looking at a periodic table, so forgive me if I'm wrong here. If it's MgCl2, Carter, what would the I value be? How many ions do I get if I dissolve MgCl2 in water? How many Mg ions are there, Carter?
I'm not sure.
Well, how many Mgs do you see in the formula?
Just 1.
Just 1. How many Cl ions are there?
2.
Yep. So if I just say, how many total ions are there? There's 1 Mg and 2 Cls, so that's a total of how many ions?
3.
3. So the Van Hoff factor, this number that indicates how many particles are dissolved in, would be 3. Okay. All right. I'm going to do one more with you here, Jack. And so I'm coming over to you. Thank you, Carter. Let's say that I went with Na3PO4. And this one's tricky because PO4 is one of those polyatomic ions. Jack, how many sodium ions do we see in this formula if I wanted to determine
3.
I? Yep, we got 3 Nas. How many PO4s are there?
4.
It's tempting.
1.
There is only 1 PO4. If I had parentheses and a 2 or a 3, I'd have a different answer. But I have 3 sodium ions and I have 1 PO4. So how many total ions are there, Jack?
Sorry, what did you say?
That's okay. I said, how many ions do you think there are total if I have 3 of these guys and 1 of these?
4.
Yeah. So the Van Hoff number that I'd use would be 4. Almost done, guys. Little m, right? That goes back to what we started with today. That is our molality, and we'll practice these calculations on Wednesday. Molality. So this was moles of solute divided by kilograms of solvent. And then this K number is just going to be a constant that we will look at in more detail on Wednesday. Okay? So we're literally just laying some foundation work for the calculations that we're going to be doing a little later on in the week. And by my book, we're getting close enough to 30 minutes that we can call it a day. And so I'm going to go ahead and